Good morning, everybody, and welcome to the session. We're going to take a look at Terraform and the capabilities of Terraform today, where you might be able to find some scripts to help you out, what we call essentially the HashiCorp language. We'll take a look at the HashiCorp language and other aspects of that. If you have any questions as we're going through the sessions, feel free to use the chat and let me know. That's one way of contacting me, or raise your hand and we can certainly address those questions as we continue through the session today. So the notes that you see on the screen will be identical to what's in the lecture book handout. If you want to use that as a reference later on, not a problem. This is part of a course that we deliver. This one specifically covers AWS, but I am going to talk about AWS, Amazon's setup, as well as Azure. And as I said, we can venture into other areas if we need to discuss, how I might do something on Google, or how I might do something on an on-prem VMware environment, for instance, because Terraform does have that capability as well. All right, so let's head into our session. Welcome to this WebAge presentation. Again, we're going to look at subjects around what Terraform is, how it works, some of the infrastructure that it's able to work with. We'll compare that to writing scripts, for instance, or doing it manually through the CLI that might be available for you as well, depending on your operations. But we will focus on Terraform here. And then some of the basics of working with Terraform. In fact, we'll do some demos around that. We'll talk about some of the additional features and functionalities that you can use with Terraform when you're trying to apply larger infrastructure projects, and that's quite common with Terraform, especially when it's not just one individual running things, but you need to have some kind of group. If you think about the CI/CD process today, continuous integration, continuous development, it's quite common that a team of people are working together, and we might need to save this information perhaps to GitHub or GitLab or some other place that makes sense to share that information. We'll talk about why we need to share it, what the state is all about, and these are all parts of aspects of Terraform that we'll mention here in chapter 2. So let's kind of delve right into our introduction to Terraform and kind of understand, what it is. So the first thing that you should understand about Terraform is that it is an open source tool. It is available for anybody to download. You would normally do that from Terraform's site, so here at terraform.io, and you would download the specific version that would be appropriate for the environment that you want to run on. Now, let me back up and say that again. You download the version of Terraform for the environment that you're working on, the OS, in fact. So whether it's a Linux OS or a Mac OS or a Windows OS, there are, again, installations for that, other types of systems as well. And so it's a matter of, coming here and working with the CLI. And you'll see that there's actually a link here on the main page at Terraform that takes you to that. You'll notice that there's different versions mentioned here. These are the Windows binaries, but you can see that there's others. I mentioned Mac a few minutes ago, Windows. We're going to use the Windows one simply because my presentation machine today is a Windows environment. But we could also use Linux, FreeBSD, OpenBSD, even a Solaris version. So depending on the OS that we want to work with, it's just a matter of installing the Terraform package. And you'll notice it's pretty simple, apt or apt-get, using aptitude here to download and install it in Ubuntu. Again, in Red Hat, you're going to use yum, and so on and so on, right? It's going to depend on the actual version of the operating environment. As I said, we're using Windows, and I'll be using the 64-bit version of this today. Current version is, as you can see, 1.16, and that's actually the version that I have downloaded. In fact, I've downloaded it here to my workspace directory, and that's where we'll be doing a lot of our demos from today. In addition to that, depending on the vendor that you're going to use or the provider that you're going to use in the cloud, you would also need to download their components. And so that would include something like AWS's CLI, so that you can access that information. So the AWS CLI, again, would be a secondary piece. The command line interface is available directly from AWS, and you would come here and simply download that and start to work with it. That, of course, will require you to have an account, in this case, on AWS. And so, again, through your AWS management console, whether you do this in a free tier or whether you're using a fully blown enterprise version, um, again, that would require some interaction with the system. So typically, that involves your IAM, your identity and access management, and from there, you would work with your users. In this case, we've got just a sample user that we use to demo things from, but that user has various permissions for the infrastructure that we might need to work with, and you can see that that's done through the policies and so on. To make this work, I need to get my secure credentials, and I would essentially create an access key down here at the bottom, and that access key would then be used to allow me to connect to the AWS features that I might want to use. For instance, I might want to create buckets whereby I'm storing my files online, and again, part of that would be to go through the process and create the bucket. Now, I can do that through the console, as you see here at AWS, but that's a lot of manipulation of the UI, and it's not very efficient to do that. So what Terraform is all about is about coming up with an efficient way to deploy this kind of information, like setting up a bucket, but making it easier for us to do so. We still need to have an account, we still need to have other things, but now I can start to use the AWS CLI, so AWS LS, right? And what I'm probably going to look at is the S3, right? The S3 example. So a lot of these commands are very similar to what you would run in a Linux environment where you're listing something, or if you're familiar with Hadoop or one of those environments, then you are probably familiar with this. In Hadoop, we say, HDFS, DFS, LS, and then we look for our folders. And you can see that this information then represents to us the same information that we can see remotely if I was to use the GUI. That's pretty standard way of interacting with AWS. So if we were to do this with Azure, I would come here and I would say AZ, right? And in Azure, I have a bunch of commands that I can choose from for things like Synapses to do some kind of querying against my large data sets, or looking at my storage, my different storage types, and so on. I even have the ability to, monitor the systems and configure various parts of the CLI. So that's a typical way that you might manage your environment. Again, if you've got Google, right, you would do the same thing with the Google CLI called G-Cloud, and here we would, go in and work with it. It's expecting additional arguments there, but essentially allowing me to interact with that environment and do whatever I need. So again, typical ways that we currently interact with things. And HashiCorp has come up with a way using the HashiCorp language that allows us to kind of write that in a script or a template and apply those changes. So essentially what we're talking about is multiple tiers here of infrastructure that we can apply via these templates, via these scripts. This generally works at this level, infrastructure level, but there are other things that we can do beyond the infrastructure. For instance, we could use platform as a service or even software as a service, maybe launch a Cosmo DB or a Dynamo DB or a Kubernetes with Docker containers setups. Again, all available to us because of the fact that the registry in our Terraform allows us to interact with these various pieces. So what is the registry? Well, the registry is, again, where we would find the resources that we need to work with. So here we would, for instance, since I'm using AWS, I would probably come up and say AWS, and you'll notice that it will take me through to the environments here for working with AWS. And again, from this perspective, if I wanted to work with, in this case, the virtual private cloud, the kind of sandbox in which my resources will be launched, I would go here and I would look at the details around working with the VPC. And you can see that it gives me quite good details on what needs to be set up for the environment in Terraform. And I've got even an example here of how to use it to provision the VPC along with subnets where I'm going to have my resources running. And again, this is how Terraform is able to do that. It provides us with this template, essentially, that we can work with. Now, it's not going to do it all on its own, and there are additional pieces that we can use that we can keep track of things. So here, an example of state on the files themselves. Excuse me for a moment. Sorry, I've been talking a lot this week. So the idea is that as we start to work with our infrastructure, we probably want to keep that information. And to do so, Terraform allows us to keep that information in what they call the state files. And we'll see some examples of that later on. Why is that useful? Well, much like a script I might write, I could then check that into some kind of GitHub or GitLab so that that information is available to me going ahead, right? And not only that, but it allows me to know what's already been provisioned on my AWS site or my Azure site or Google or wherever else I'm keeping the information. But technically, I don't need to be a programmer here, right? If we think about other ways that we apply infrastructure, in the grander scheme of things, often we need to know programming languages like Java or Python, or today, TypeScript is quite common if I'm using something like the AWS CDK, the Cloud Development Kit. Here, I can take these patterns that they've put together for us. I still need to understand the AWS or Azure or Google platform because I'm going to need to use those keywords in the registry to be able to work with the resources that I want to deploy. So there is still that need to understand how AWS works, how it is integrated with the features and functionality that you want to use. We can't forget about that overall, because that would cause us to have a problem with the actual environment if we didn't. So again, we need to understand AWS or Azure environments in order to take advantage of this. But essentially what we're looking at is this automation via some kind of configuration management tool, or via what we call, continuous integration tools. Now we can do that on our own and manage that on our own, or we could use Terraform's cloud environment as well. So we do have some choice here when it comes to working with Terraform itself. But essentially, it's an open source tool. It provisions and allows us to do changes to our environments. It supports this idea of infrastructure as code. Also allows us to do cloud provisioning. So we've been talking about, AWS and Azure and so on. But we can also do stuff on-prem, as I mentioned earlier. So it will work with VMware, for instance. So if your requirement is not to do something with, let's say, a cloud, but you're thinking about doing this internally, there are lots of choices when you want to do that. And you'll see that A lot of them are listed here. Here's our VMware vSphere that allows us to create those uh, virtual machines that we might want to move to the cloud, or that we might want to provision in our own environment. And so, again, these kinds of um, uh, registry components that you can take advantage of really do let you work with a lot of setups as required. And I did mention about Azure. So, if we went into the Azure environment, we could see things like here, Azure RM. This is the resource manager that's used to work with the Azure environment in, again, Microsoft. If I went and said Google, we would get Google, and so on, right? We're going to concentrate on at least two environments, because if I go off, I'll do about three or four, then it will start to really get confusing. But the idea is that we can automate things, and we can modify and monitor and change as required those environments, because we've kept the information in a state file to work with this. So again, we'll see some of those coming up as we go through. So again, cloud providers out there, lots of others that you can launch your tools on. And essentially, by using the registry, we can take that information and deploy it uh, in a simpler way. Not only is it versionable, it's testable, it's repeatable, right? Those are the things that we generally require from our provisioning side of infrastructure or resources. And this is a nice way of working with it. And technically, since it's text, it's very easy to use that to be able to check into not only a version control system like GitLab or GitHub or Git or Bitbucket, but we can also use it in a distributed VCS as required, meaning that we can use something like Jenkins, perhaps, if we wanted to, as part of the check-in process. It has plugins for this. So again, lots of opportunity here. But the idea is, from the infrastructure as code point of view, we do have that versionability, we have the testability, we have the repeatability, and we have the auditing capabilities. Again, you do have copies of these notes that you can download, so the lecture notes are there. And again, if you wanted to follow any one of these um, links that are here in the notes, please do follow along in the PDF, and you can certainly go there. From time to time, I will put links in the chat as well. O'Reilly has a great book on this idea and concept, and why this has become sort of a de facto way now of deploying our environments, because it's so much easier, right? It simplifies those deployments for us using this infrastructure as code. Not only that, but again, that auditability and other things make sense. Now, what's the alternative? We've seen one alternative already, and that is that I can go to my command line, right, in my CLI, my command line interface, and I can start, typing things like AWS S3, get an LS of that, a listing of what's in that bucket. Now I could go in, and maybe I don't know all of the commands, so maybe I come here and I start saying help, and it's going to show me, again, additional information. For those of you that know man pages, this is very similar to that. So here it talks about, how on the CLI, here on the command line, this is what you can do. And you can start by, creating the bucket and setting up the values for it. Notice we've got MB, RB, right, LS, these various commands that we would use. But it gets tricky, because, to run this, means that I need to know those commands, and I need to know exactly what they will do. That's not to say that there isn't other ways that we can do this. So, programmatically, we could start to write code, I suppose. This will do the same thing. It will help me provision again in the cloud. In this example, we're using the AWS CDK, the AWS Cloud Development Kit. We could also use the AWS SDK, the Software Development Kit. And by writing some code, right, we've got our class of code here. We've got some properties that are associated with the various pieces that I want to utilize in my application. Then I could simply come here and start to do something like, CDK deploy, and that would allow me to do it. Actually, I have to do Bootstrap first, but because I have to make sure that the application is able to uh, connect and bootstrap up my environment at AWS. So I've got to go through this kind of bootstrap environment to create a stack on AWS and then run it. In doing so, right, I can start to provision my applications, but it's a lot of code to write here, and you can see there is a lot of code, right? A lot of information that I still need to know about if I'm using the CDK itself from AWS. That can be quite overwhelming. Not only that, to maintain that, plus manage all of those properties, it's quite complex. It's saying here I've got a folder missing. That's all. I'm not really going to worry about it. I was just trying to give an example of kind of the things that are going on here in the background. But this is another way to do it, right? If I want to move some data, like the sales pipeline data here, to AWS, then I have to go through and use, right, the libraries here to do so and manage the infrastructure. Perfect, can do it, not a problem. There's just a bunch of things that need to be configured and set up and provisioned, right? So we do have other ways, and I don't want to take away from those other ways of working, but I can tell you that Terraform does give you some advantages. First off, I can use templates, and those templates are going to be reusable. Now, what do we mean by a template? Well, essentially in Terraform, whether you're doing this for AWS or whether you're doing this for something like Azure, you basically create information that is in a template form. So let's say that we were going to do something like an S3 bucket. And inside of the S3 bucket, I'm going to put a file like sales pipeline that we saw a moment ago. Well, we can use the HashiCorp language to work with our provider, in this case, AWS, and we can start to provision information. So the first thing we'd want to do is set up where, right, we're going to deploy this bucket. So in the case of AWS, in a region, and then we need to give the bucket a name to work with, right? It should be unique. So again, we would make some changes here, but essentially, if we're going to deploy the bucket, we want that bucket to be unique. Inside of that bucket, we have to decide what we're going to deploy. So in this example, we're deploying an index.html file. It's public readable, and it's going to be displayed inside of this bucket. Remember, the bucket needs to be unique. So we would have to do something to make it unique, maybe, I don't know, dash 007 dash Kevin. I don't know. All joking aside, it has to be unique. So you want to make sure that the bucket that you're going to deploy has some kind of unique naming convention. Now, we don't generally hard code this stuff inside the file. We would use a variable to plug that information in, and we would have some kind of generator that's used to generate the bucket names and make them unique. So again, there's some other features and functionality. I'm just trying to show you the template as it sits. And again, who's going to access it or not, right? We can set permissions. We can set um, encryption, we can set versioning, right? Anything that's capable of being done when we work with our S3 environment in Azure is capable of being set up here in the file that we want to work with. So that's one of the main takeaways that I want to make sure that we understand is, as long as there is support for the type of provisioning that exists here, then the registry inside of AWS that we download should allow us to work with and provision things in the same way. For instance, here we've got a bucket, right? The bucket is essentially the bucket that I'm calling here. And inside of that bucket, for instance, here's a stack. Inside of that bucket is where I'm going to create my folders and my files, right? That's just the organization of it. It's a hierarchical structure in S3. So from this perspective, when I push that information up, it'll go inside the bucket, and I'll have some kind of source for where that data exists. Again, there's a bunch of additional things here to ensure that when the bucket pushes the details up, it uses MD5 to ensure that everything rightly goes where it needs to. But these kinds of scripts, again, what we call templates, are essentially uh, creating that environment for us. It's simply easier to read and work with than having to do something inside of, programmatically inside of a language like Python, TypeScript, JavaScript, any of the languages that can be used uh, with these environments. Also, what we get is automation. So once we start to run our commands, essentially what's going to happen here is we can use special keywords in Terraform to make sure that whatever we have in our script is going to work. So first off, we would normally use a special command like Terraform plan, and then we would apply that plan, which would create the infrastructure. We can also take the infrastructure back down if we need to. We can also show what infrastructure has been provisioned or is existing. So there's a lot of different commands that uh, basically give us what we call extensibility, right? So the extensibility of this really is the provider registry that we saw a few minutes ago, whereby that provider registry gives me access to all kinds of different things from that provider. So here in AWS, right, you can see that there's all kinds of other ones out there. I would normally go with official and verified ones, but the community also has additional ones that can be used. And you could always take them as a sort of a starting point for something that you might want to provision. So in here, right, you can see we've got AWS, and these are the ones that are available. There's a lot more of them, right? A lot more of them here that we could choose from, depending on what we're doing. So whether it's creating, the VPC, or whether it's creating something else, there's lots of great examples, and lots of modules out there that you can choose from to deploy with. Again, I tend to stay and recommend that you stay with the official images, because these official images allow you to do a lot of the normal types of deployments that you may need to do to your environment, whether it's in Azure or AWS or in Google. So you can see here, maybe what I want to do is work with EKS, Elastic Kubernetes. And I would go into the module, and the module itself would give me details, right, of what can be done, how my resources need to be set up, roles and other things that I need to have permission for. And then it's a matter of setting up the modules. Again, since this is EKS in this case, it needs to have perhaps some location to be set up in. So we've got the VPC here and our subnet to deploy that resource. And then within that, what is it that we're going to deploy? So in this case, they're deploying a couple of instances of an EC2 with an AMI, the AMI being the Amazon Machine Image, or the virtual machine image, and they'll deploy that onto those environments. So notice, one of these and two of these would be deployed. And then from there, we would essentially start up our kubectls and our kubelets to basically integrate EC2 with our software, whatever it is that we're going to launch on top of this in probably a Docker container to run. Again, you can see some of the notations here of how that's done. This one's getting it from the repo. There's lots of repos that you can work with, and Terraform has a number of them whereby this code is already available for you to work with. Again, what you're going to do is modify that to your specific needs. And that's why I said before, you still have to have an understanding of the cloud provider and the cloud provider environment, because you are working in tandem with them, right? So you're using, your permissions that you have for working with particular roles or service roles, and provisioning out the hardware or the software that is important for this. So again, something to look at. There was a question about documentation. The documentation's in the handout section here. So you will find the documentation that we're looking at in the handout section. Okay. In addition to that, the documentation itself, like EKS, that comes from Terraform. So it's a matter of going to Terraform and looking at their specific information, so terraform.io, to see that. That's where you will find that specific documentation. And the registry itself, right, you'll find the information here with examples. And in fact, as I said, this comes from GitHub. So if you go to GitHub, you'll actually find the complete information about deploying an EKS module. So again, running your Kubernetes module. So the examples are here. There's a README file. It's GitHub, so you should have a README file that you can look through to understand that. Or you come to one of our courses at WebAge, and we can certainly take you through that and how they work. The state is important here, and we'll talk a little bit more about state. But essentially, when you launch or you provision something in Terraform, Terraform keeps what is known as a TF state file. This is an example of one. And the initial TF state file is generally pretty generic, right? When you start, it creates this generic TF state file that is basically going to keep track of, and this is the important part, the lineage of your deployment. And what do we mean by that? Well, the first time you deploy something, right, it needs to know what was deployed. But each time after that, if you start to make changes to that file, then it needs to be able to write that information somewhere so it knows what has changed. And again, this is often done in a local file. As we see in this example, it's the TF state backup file that I'm showing you here. But essentially, this is the information that goes in the state file. Now, we don't generally modify this. We modify that original HashiCorp language file that we looked at for the S3, and it will then update these files. Both the state file and the backup file get updated for us in this manner. So this is quite common for working with something like this is the S3 bucket example, whereby I deployed a bucket. It talks about the bucket name, right? Talks about the region, whether or not it was replicated. In this case, it wasn't. We could also have information about maintaining it. Should I decide that I want to drop that, then again, this is something that we would look at overall here in the information. So the kind of an example of these that we would see overall for the applications that we're doing, whatever that may be, right? We would have lots of applications that typically are used here in these environments. So from that perspective, we have lots of operations that are there. Could that state file be used to move from one cloud provider to another? Not really. So the state files themselves are specific to the environment that you're running, the provider that you're running, right? These are AWS commands. So they only work on AWS. If I'm doing this in Azure, they're going to be similar in the commands, but the provider is going to be different, and they may have different names and so on that they use in their environment. So you can't just copy one and essentially move it to Azure environment. Let's take a look. This is an Azure example. So Azure, of course, has a different provider name, right? We said that earlier. This was AWS. Now it's Azure, right? Resource Manager. It also has different naming conventions for things that it uses. For instance, West US 2. Whereas if I'm doing this on AWS, right, it's US-West-2. So there are several differences between them. Also, for the resources that you're using, they may have different ways of doing it. For instance, in AWS, we use something called a VPC, Virtual Private Cloud. In Azure environment, we use something called the VNet, which is a virtual network. So again, slightly different reasons for this. And in particular, here, this is the one I'm provisioning at this particular time. But what's going to happen is, as I'm making changes, the backup file itself keeps track of those changes that I've made. Now, why? Auditing, right? We need auditing here. So I need to know what's happened in the past. And so that's why the backup files are used for us, right? So again, this gives us that capability um, of working with the files and the various other pieces that we're using here. Was there any other questions on that part? Yeah, okay. Yeah. So we're seeing here, different script types and so on that can be used. I've given you a couple of links to those if you want to go and look at them. We don't provide the ones that are here in that I'm showing. Those are part of our class that we actually run a 2-day class on Terraform. And again, it's a hands-on class, so folks actually learn about how to write these scripts and then use them in those classes. But I have provided an example of the GitHub link that I showed a few minutes ago. So if you want to explore that for yourself, then yeah, the code is here. And in fact, if you go up a couple of levels here, you're going to find that there's all kinds of modules available around different types of platforms that you might want to work with in those resources. This is just the AWS one, right? So Terraform AWS. But if I went to the Azure side and I clicked on one of the links at Terraform for Azure, I would be able to again see, different coding, right? Essentially the scripts that are available from Terraform. Again, caution on those, though. Those are generic. As I said, don't start deploying one of these immediately, because obviously that won't work in your environment. You need to get the particular script that makes sense for the environment that you're in. So just a caution on that as you're going through. Would it track changes done at the portal? Yes, it can. There is a way to do that, Rosa. So Terraform has a couple of additional commands that can be used to basically pull down what has already been set up in your remote portal. We can, if we get a chance, I can demo that. But that is possible, yes. Now, again, that would give you the starting point. Anything that would change then should be done through the Terraform scripts themselves to keep that in sync with what's going on in whichever portal you're using, whether it's AWS or Azure or whatever. So again, things to be aware of. Preview the changes. I mentioned about that a few minutes ago. Reusability I mentioned. Parallelization of operations. So what if I need 10 machines? Well, we just saw in the AKS example, that you can do that, right? So here in the examples, working with your module, if you're setting up a group of machines, right, then it's just a matter of provisioning the grouping of those machines and saying how many you want. Again, this is all possible. And that means that I could launch 10 machines, or I could launch 2 machines. Or if I've, done my homework and I understand how things work in AWS and Azure and Google, I probably know about something called auto scaling groups. And I could say, well, the minimum I need to deploy today is 2, but I want to have that scale up to perhaps 10, right? So again, this is something that we could keep track of and work with in the environments through Terraform. And it's certainly, important, that we understand that provisioning of how this is done. How can you ask questions using the chat? Didn't you just ask me a question? Sorry. I believe the chat's enabled to do so, but you should be able to do that. If not, just ask them here in the question section. How can you tell which script templates are officially provided by the vendor? Yeah, so going back to Terraform and the registry for a moment, if we look in the Terraform registry, what we'll find is that there is a specific piece in there that you could click on, and it will show you official as well as verified resources. So just over here, as you come in, let's say we just browse for providers generically. We don't know which provider we're going to use yet. You'll see over here on the left-hand side, these tier tags. So if you turn off community, now you're looking at official and verified scripts. So you're not going to get something from the wild, wild west, right? They want that though. Sometimes AWS, doesn't have examples of everything that you can do, and you may need to go to a party that is not officially verified scripting. As long as you understand what the scripting's doing, right, then you should be able to take that as an example, much like the one I just showed you for, EKS, and you should be able to use that example and make modifications to it. Remember, you still have to understand AWS, and we have to understand all of those pieces. That's something that needs to be done. You don't just jump in and start using it and hope that something's going to work um, for that. So again, be aware of that. Cloud agnostics. Yeah, I have a problem with that term that Terraform uses, just to be completely honest, 100%. They say, oh, Terraform is cloud agnostic, can work in any cloud. Yes, it can, but you have to have a provisioner for each of those, and you have to have your registry for each of those. So typically your scripts are specific to the environment that you're working in. So for example, just to show you an example here, right, you can see that these are the lab files for the course that we teach, and it's in Terraform in Azure. And these are Azure specific commands. Why? Well, because when I download this, I have to be using the registry for Azure. So in this case, I have to make sure that that Azure registry is there. If I'm doing the same thing in AWS, for instance, right, I'm going to download the Terraform piece, but I'm also going to download the AWS CLI piece, and of course, any other additional pieces that I require. Now, Terraform will tell you that you can create one file to do everything, and they call it main TF. But they do then suggest that you create subfolders for that to work with the other resources. And then they come up and they say, call it main TF again. That's also something that I completely disagree with in the organization of my resources. And so in my case, I always give them a specific name. And even into my file name, I don't call it main TF. It just has to be called .tf somewhere in a folder. But I generally get specific about what I'm provisioning. Why? Because when I check that into a repository, it's going to be very difficult for me to find that if everything's called main TF. So, again, I'm a little bit more specific in what I do when I provision it. And that's something that we actually discuss, in our classes as well. So again, these are, pretty generic. Could I have them all in sort of the same folder and provision it? Yeah, as long as you have downloaded the CLIs and you have the appropriate credentials and so on. Yeah, you could mix and match if you wanted. It just gets very complex to keep track of the resources. If you have thousands and thousands of resources running, and that's possible in AWS or in Azure or in Google, mixing and matching those, not a good practice. So, from a best practice point of view, I generally keep my providers separate and I keep them separate in folders when I'm actually provisioning uh, those individual pieces. You can't take one generic file and provision everything. That doesn't work because of the specifics to the environments that you're in. The cloud providers have different naming conventions. EKS is AKS, is GKE, right? So because there's different uh, naming conventions and configurations that we have to consider, the best practice would be to keep them separate. Uh, but at the same time, if I needed to launch all of those scripts at once, again, I could do that, right? So that doesn't really prevent me from going through and updating for each provider some change that I need to make and then deploying it globally to my infrastructure in my multi-cloud environment. That would certainly be possible. So I just want to caution about that. Um, Overall, um, this is certainly something that you want to think about. So again, we'll get through some of this and talk about what's the advantages and disadvantages and so on. Look, there's other automation tools, right? I just showed you using CDK and CloudFormation, right? We could do that. You need to know a language. You need to know TypeScript, JavaScript, because TypeScript works with JavaScript and converts your TypeScript into JavaScript. You need to know Python if you're going to work in Python. You need to know Java if you're going to work in Java. You need to know Go if you're going to work in Go. You need to know programming languages. And if you're not, up on that, and a lot of data engineers aren't today, they may have some background, but not complete backgrounds in that. What we're really looking at is a way to make these simple for us. The other thing is that we don't have that state capability using CloudFormation. We don't just have the capability of keeping track of that from an auditing point of view. We have to use third-party tools to do so. So Terraform does give us a little bit of that here as well. And there's lots of configuration management tools out there. So this is just to say, look, we understand that this is one of these tools, one of the many. And I said, you could do it from the CLI. You could do it with the CDK or with an SDK. Absolutely. But now you're getting into programmatic aspects that often overwhelm, the data engineers. Or even the data scientists. We see a lot of that combination today. I actually have another seminar I run around, what's happening in data science and data engineering in 2022, and it's amazing to see, the uptake and the blurring of lines between what the data engineer needs to know, what the data scientist needs to know, and what the data analyst is doing. And we're hearing new terms out there like AI ML engineer. That's not somebody that is simply a data scientist or a data analyst. It's that combination of those capabilities, and so that reflects often in what you're doing. Terraform tends to be a good way of managing that infrastructure. In particular, ramping up those resources in a very quick manner, and also keeping track of those resources, um, when you're dealing with them. So, again, this is something to be aware of. You actually have the ability to make your presentation full screen if you need to. So, here's the idea. We have basically some machine that's running our Terraform application. We have our configurations. We have our state storage, probably on Git, if we are working with remote states for, a bunch of other folks. Maybe it's Git or, GitHub or GitLab. I mean, all of these are very popular today for CI/CD. That's not saying that you can't use Bitbucket or Subversion or something like that, but we see a lot of organizations using these specific ones. And then we have our providers, right? Whatever provider it might be, and plus a whole bunch more, right? Out here today that it takes advantage of. Or if we're doing this on-prem, as I said, this could also be on-prem. So one of the strengths here is that those low-level components that we need to work with, like the infrastructure itself, we have the ability to deploy it in a very quick manner with very small template scripts, as opposed to something that requires us to programmatically create classes, methodologies, and so on inside of those classes, all kinds of other structure. So this is a simplification essentially of the infrastructure that we want to provide. And it could also work with, so that's the low-level components, but it can also work with the high-level components. As I said earlier, I could provision my VPC, for instance, or I could provision my software as a service infrastructure. Maybe we would provision something like Cosmo DB, right? So Cosmo DB would be a good example of something that I have the ability to deploy without doing too much work. So, for example, here's Cosmo DB. So you can see this one's Azure, because that's where Cosmo DB exists. If it was AWS, I'd be doing something like DynamoDB. I've got my resource group that I'm going to create, and my resource group is going to be created in a certain region. Again, this is AWS stuff that you need to be aware of to be able to work with it. And then, my account, right? So here's my account that I'm going to create called Cosmo DB WA for WebAge. It's in US West 2. We'll get into these variables shortly, but essentially you can create variables that can be transposed inside of your files. So again, these could be generic, and then the variables could be given on the command line that would then substitute, or interpolation would happen there for the values inside the file. That makes sense, right? Then it's reusable because as I go to deploy it, I provide the variable names and so on that are appropriate for that. And then whatever other things that I need to do to set up my Cosmo DB instance. But that's essentially all there is to it. I'm not writing that large code that we saw, a few minutes ago in the CDK, right, in TypeScript, that then gets translated to JavaScript and then gets deployed on CloudFormation as a stack. And then on the stack, I need to decide when I'm going to run that stack and have it, provision what I need. And again, these are all reusable. So the installation of that gives us that extraction for deploying whatever we need wherever that might be. Could be on a Google environment, could be in Azure, could be in AWS, could be on our on-prem system with vSphere. Doesn't really matter what we're doing. How it really works is the configuration files basically talk about the components that are going to run the application or your entire data center. So again, those files can be quite large if you want. The example that I showed on, again, EKS a few minutes ago, if you look at the details there in those files, they are quite significant, right? And the detail down here is quite significant. There's a lot of pieces that are being managed here, right, by this file to deploy an EKS instance, Kubernetes with our containers and so on. So these are things that we have to be aware of when we're using something like Terraform, it's the same kind of descriptions that we would have if we were getting into using any of the other types of provisioning, whether it's the command line or whether it's something like, um, I guess, CDK or SDK, if that's the case, for the application that you want to run. Um, really what happens is it generates an execution plan. So the first thing that it does is it goes out and looks at what's out there already. What have you provisioned? And as I said, and there was a question earlier on this, um, can I get my current state of everything that's running? Yes, of course, absolutely. And it will get that and list it down, whether it's AWS or Azure or Google. It then generates an execution plan around what it's going to do. So it figures out what's out there and says, okay, given what's out there, these are the changes that I'm going to need to make in order to deploy the application. Perfect. Then it executes it. So it basically takes that information from the configuration file, right? Later on, if I change the configuration file, Terraform does a diff. It looks at what's available in the infrastructure currently, and it says, oh, there's a slight difference in what you want to deploy now versus what's deployed out there already. And again, we're going to see some examples of doing this. I'll go through and do that. There's a question in the chat about looping. Yes, absolutely. You can do looping. Makes sense, right? If you need to have 4 machines provisioned, then yeah, it's going to loop through that and it's going to look after that information. Whether it's in the resource group of Azure, it's going to put it in the particular resource group that you say, or if you're doing it in the VPC within the resources, again, it can be created as a group of those if you need. You can do the tags. In fact, we do the tags while we're doing it. We don't go out back and put a tag in later. Why would we do that? We could use the loop to basically create the tag names that are required for that resource. And so using these methodologies, you have a lot of options when it comes to deployment of your solution, whatever that might be, for your overall state. I'll show you an example. This is getting a little bit ahead, but I'll show you an example of what we're talking about here. So here is AWS. We're deploying inside of a block our resources. And I'm going to do a grouping of resources that are going to be set up under these different subnets. Notice that the subnets are brought in. And then down here, I'm going to set up outside access to these resources for whatever I'm going to provision. So not only can I set up the information, this one's an example of doing a load balancer that's listening on different ports in different subnets, right? And again, this is something that we could do. In a larger application, I would probably set up a bunch of web servers maybe that I'm deploying here. And again, that load balancer would be what is essentially allowing me to work between those different environments, which is a pretty common scenario. If I'm working with some kind of instance, whether it's an EC2 instance or whatever, then I need to specify the instance type and the image that I want to use. That's the VM image that would be used here for that. The tags are added in directly, so any instance that you create, if you want another resource group with a different image, you can add the tag at this point. Or if I was doing a loop, I would probably have this as a variable where I'm adding to the end of this to say instance 1, instance 2, instance 3, and so on. But that's essentially what the capabilities of Terraform have. So if you need 2 or 10, all of that's possible in Terraform as you're walking through. So the file itself keeps track of that. And again, this is something that you would do. Somebody asked about automating um, alerts. Yes and no. Depends on what you're doing. In a larger environment, you're not going to do that at the Terraform level. Those alerts would be on your AWS or Azure or Google environment, CloudWatch, or some other tool that you would be using for alerting. Because you have to think about this as in a global way, not just as one instance of these systems. How does that globally affect your environment? So you wouldn't necessarily set up alerts at that level. I mean, if you have something like Nagios or something like that running, Grafana or Splunk running locally, and you want to set up some kind of information about that file being changed, yeah, sure. But Jenkins or other tools that are part of your Git, where you're making those changes and saving that remote state, those are going to have alert capabilities anyway, because when something's checked in, right? But at the higher level, on the actual provisioning of resources, you're going to do that at the AWS level or Azure level or Google level or whoever the provider is. So as we said before, these are the important examples. The terraform.tf file, whatever you desire to call it. By default, it's called main. So often you'll see, folks have a main.tf file that they're using. As I said earlier, don't do that. I actually think it's better to give them individual names for the type of application that I'm building, because to me that makes more sense, right? If I'm building something specific and I need to make sure that gets deployed, then I want to make sure down the road I'm able to find that resource. Another way to do that too would be to kind of do like we do in the courses, and that is basically give the folders specific names as well. So this is something that we would typically do. So the folder then represents the structure or the infrastructure that I'm working with. Terraform init basically is where we start off, and for example, in this workspace. So let's just do a look at my workspace. You'll notice I only have my Terraform exe here. Now, in a real environment, that Terraform exe is probably going to be someplace else. And in my environment variables, whether they're system environment variables or whether they're local environment variables for my user, I'm going to have a link to that resource. In this case, I put it here just so you could see it. This is the AWS version of that. This is the 64-bit version. And if we do something like Terraform, we can get information about what can be done. So these are some of the commands that you have access to. Some of the ones that we were just talking about on this slide are right here, so the main commands. So just to show you kind of an example of that. So you see Terraform, and you can see init and plan and apply. You can also see destroy. Validate's mentioned here. There's a couple of other things that we can do beyond that, just to make sure that our code is valid when we write it. But essentially, these would be the ways in which we would work with it. And then most likely in this folder, we're going to create our TF file, or we're going to make a folder, and under that subfolder, we're going to have our TF file that we'll use for that. You can see that there's other commands available: login, workspaces, testing, state, right? So advanced state management, show, which gives us, of course, the current plan or a save plan that might be available. Import, so we can import existing infrastructure. Somebody asked me about that earlier. So this is the command. You say Terraform import, and it goes out to S3 or whatever environment that you're looking at, and imports that for you. Gives you or creates for you essentially the TF file. There's other commands that can be used here. So the first thing that we would most likely do would be to start working with our file, right? And we would start to create that file and do something with it. So just as a quick example, what I'm going to do here is I'm going to bring one of those files I showed you earlier. So I'm going to bring in the S3 file, and I'm going to put it here in my folder. There's my S3TF. And that S3TF is something that you saw a few minutes ago. It's basically that bucket example that I was showing you earlier. Now, again, we want to make sure that this is unique. So, I don't know what I can call it, but that hasn't been used already, but let me do something like this. So I'm going to give my bucket a name. Now, notice I didn't change it down here, and I'm doing this on purpose, okay? So let's just save this example in the way it is. Let's go ahead and do a Terraform init, which is, of course, the first command that we need to do, because that's going to create the TF state file and so on. So Terraform init. And again, it's initializing the background information. So before, all I had in here was my Terraform exe file and my S3 file. Okay, so you see that, again, wouldn't normally have my Terraform exe there, but just for this purpose, so it doesn't interfere with anything else that I'm doing on my presentation machine. That's why I'm doing it here. So let's do a quick dir. No, okay, so look at that. It created a .terraform folder in this file. So let's look at it visually because, again, this is easier to see. So here's my provider. Notice it says registry.terraform.io from HashiCorp, AWS. Why AWS? Why did it download AWS? Well, S3, right, in that file is a reference to AWS. So that's why it says AWS. We said HashiCorp, AWS. So Terraform recognizes inside of that structure of that template that I'm going to deploy something to AWS, and immediately goes and downloads the resources for allowing me to do this kind of deployment. And specifically what it's downloading in this example is the modules that it needs, right, to work with AWS, and in particular to work with my S3, right? So the S3 deployment that I'm going to do here. Now, as far as that goes, we want to see whether that will actually work. So the next command that we're going to do, not init, we're going to do a plan. So again, in the example of what we're doing, these are all part and parcel of running Terraform. So let me run Terraform plan and see what it says it's going to do. Look for plus symbols here. All right, oops, look what it says. Oh, you have an error. Now, remember I said Terraform validate. We didn't validate the Terraform piece. And it's saying to me, oh, on line 40, you've referred to this bucket as my bucket, but I don't know where that is. I can't work with that. So Terraform is smart enough when we use this kind of application to quickly check through the file, right, and identify the bucket. Look what the bucket name was here. Look what it is down here. Oh, so I need to make sure that I'm calling that same bucket anytime that I need to work with it. We have one other problem, and that is that this doesn't actually exist in the folder that I'm working in. So what I'm going to do is I'm going to just modify this quickly, and I'm going to bring from my example course that we run, I'm going to bring that information in so that we can successfully deploy this and show you essentially what's happening. So let me copy over the data folder and put it here into my same folder in Terraform. So here under my PC in the workspace, I'm just going to create a folder for that data file. So just to show you that, again, I've now copied in the data file folder, and inside my data file folder, there's the index.html. So you'll see that Terraform's smart enough to know that if something's missing, to give me a warning about that, as it did, right? Because I didn't do validate first, that warning was picked up and was told to me. So let's go back and see if we can run our Terraform plan now that we've got things better arranged in our system here. So Terraform plan. Again, look for the plus symbols. If we're successful in doing this, we should be able to see that information. And what goes on. Now look at that. It says, wait a minute, there's something else that's incorrect. So again, each time we're going through here, it's calling out where there might be some kind of difference. Now, what happened was, right, I didn't save that information. So even though I created my directory, which was back here, right, I didn't save it in the S3 file. So again, it's checking to make sure that everything that I'm doing is correct in the way that I'm locating and working with this information. And it's correct. It looks like it's there, but what did I forget to do, right? I didn't save it. So again, validate stuff for me, which is the important piece here. I'm not going to have mistakes that are going to happen with the application of my uh, application, right? So again, look at this and saying, oh, well, I can't find that in your own local folder because I'm not running it from there. I'm running it from the workspace. So I need to make sure that I'm specifying the actual directory where this is coming from, right? So C:/, right, workspace. Again, the best way to do this is, to run it, see what it does. So there's the path. Let's see if that works with the C:/, workspace. Right, so let's go back here, rerun the plan. All right, now it says, wait a minute, you're getting an alert here. Terraform wants to access the outside. So I have to allow for that to connect to S3. And that's simply my firewall here on my local machine. There it goes. Perfect. Finally, we've got our pluses. And again, let's go up and see what this is actually planning on doing. So essentially what Terraform plan does is it goes through and says, oh, you want to create some new resource with a bucket, right? Remember, our buckets are going to go out here in S3 because I'm using AWS S3. I'm going to create a new bucket out here in which I'm going to put that file that we mentioned, the data file that is index.html, in that location. Notice it says, I see you want to use an S3 bucket. You want the bucket name to be my S3 bucket, blah, blah, blah. Here's the bucket file that I'm going to create. Here's the tag that I'm going to give it. So notice that it created its own tag for MD5. And it's going to be a public readable folder. So now, if I'm happy with all of that, right, all of those pluses are changes that I'm making. If I'm happy with all of that, I can tell it, go ahead and apply that, right? Apply the script, apply the template in AWS. So what you should see, again, is those values going out. Oh, and by the way, I could have said -y, so I don't have to see all of this, but here it says, do you want to do that? I'm going to say yes. You could also have it auto accept that, so you don't have to say yes every time. Especially think about scripting, right? If we were running this on a machine and we want that script to launch at certain times of the day, right, we would probably do something. Now, look at this. It says, wait a minute, I still have an error here trying to do something. And it says, the S3 bucket object source doesn't exist. I can't find the path to that bucket, right? So it's still looking for the Terraform S3 demo file for that. So let's go back and take a look at the file, make sure that everything is correct again in the file, right? So I've got my workspace. Look at this. There's another source piece up here. This source piece down here was for the actual MD5 of the file itself. This source piece up here is saying where to find it. So again, right, we need to be correct in what we're doing. This is basically what people struggle with more than anything, is getting all of these things correct. But once you do, right, once everything is correct and once everything is provisioned correctly, then when we go back here and we do our apply and everything is right, it should be able to go through and create that bucket for us. There it goes. Now we can see whether that bucket was created. Remember, we've got all kinds of ways of doing that. So here, say yes. There we go. So from the command line, I can say AWS S3LS. There's my bucket, right? My bucket, blah, blah, blah. Okay, perfect. So we know that that bucket supposedly got created. And supposedly, we've uploaded something into it. So let's use another command here at the command line, just as an example. Again, I'll show it to you another way in a moment. Let's go and look under that bucket level and see what's there. So AWS S3 LS, my bucket name, right, with a slash on the end. And notice it says there's an index.html file. Now, graphically, we could prove that as well, right? So again, let's do a reload on our page here. And we should see that the bucket exists. There it is. Notice the connection date and time, right? It's correct. And if I go underneath here, there's the index.html file that I just created. All right, so provisioning and using this, fairly easy way of doing that. Again, lots of other options here as well. Jeffrey said, is it possible to use star instead of an object key? Yeah, there's a bunch of things that can be done. As I said, there's also the ability to work with variables here, which we would more likely use. When I do my Terraform apply back here, I might pass in a variable instead that includes all of the information that I want. And typically those get stored inside of the same folder that you're working with. So it's quite common to create variables that you would apply to your application, specifically for environment pieces that you might have. For instance, I'll show you an example here. Right, here's an example of something that I might do. Right, so you can see this would be my Terraform Azure CLI connections with my name and password. By the way, this is not valid, so don't worry. If you're trying to take that and use it, won't work. But those variables could be used. And now I could use that variable across all of my different applications, right? So kind of like a secrets key. Again, there's ways of working with the AWS secrets if you need to, a whole bunch of other things that can be done here. There's a whole bunch of other options too. We'll get to the out options and other options, Soros, in a moment. I've got some other stuff to talk about. First, curious why you wouldn't run the validate plan again after fixing. Yeah, I would. I would normally do that. Absolutely. I was just trying to show you what happens if it's not valid so that you can get an idea of the messaging coming back from Terraform. It's just part of the demo. In the real world, we would do a whole bunch of other things as well. And in fact, I wouldn't run this at all by hand. I'm probably going to use some kind of Unix script, cron job, something like that. I suppose a Windows service could do the same thing. Wouldn't be doing this by hand at all, right? My provisioning would be set up in some kind of pattern. After I check in something into Jenkins or I check into something to GitLab, it's going to go and do that work for me. It's not going to be me doing this by hand. But again, all of these pieces would certainly be available. Neil said, why didn't it detect the last error? Because it sometimes doesn't read inside the file, pieces of the file. So that's why it didn't get the bucket name. It was only looking at the last bucket name piece. Again, validate's okay. There's some other things that you can do. To-year file format is another one. If we just go back to the Terraform commands here, one of the commands that I would normally run first is format, and it formats it in correct syntax for me. That means that all of my files would be formatted in the same way, and if somebody was coming in to read them, then obviously that formatting would be consistent. That would be one thing that I would do. Again, the validate only can validate so much, unfortunately, in the way that it works. So I would use additional pieces inside my script to do that, kind of like writing a script with if. There's a whole bunch of other things that would be done here to ensure that the file is correctly formatted. But I intentionally did that. Sorry, folks. I should have probably said that up front, but it was my intention to have it fail so that you could see it fail, and then finally to actually deploy correctly. All right, so and again, you can see this is the original file, right? So in this case, if I had that under my own user account, I've just created a workspace folder this morning to demo this stuff. But in my own user account, if that is sitting there where it should be, then this would have run without any issues at all, right? The idea was to show you those. So we saw plan, which tells us sort of what's going to be done. You saw the green pluses, and I do want to make sure that you understood what was happening there with those green pluses. That's representing the change that Terraform is going to make. If I go and modify my file in some way, and I then reapply it, what we would see, of course, is the changes represented by Terraform again here. So again, if I made some kind of change, like changing it to go to the west or the east, maybe we decide to use US West 1, right, instead. Let's do a file save. Let's make sure it's the right file. No, it's not. So let me not save it there. Let me open up that folder and work with the right file. Again, I'm showing you some of the solution files as well as my files that we're using here. So let's go into this one and let's make our change here as US West 1. I think this account has permission on that folder in that region. And let's go back now to our Terraform plan. And let's see what it tells us. I did save that, right? All right, so notice it says error reading it. Guessing that's me, not it. Workspace. Yeah, that's correct. Yeah, and so again, notice what it says, right? Incorrect region, right? So I don't have permission to work with US West 1. Let's try something like East. US East. Let's see what happens here. Should be okay. Yeah, so I save that. So let's go ahead and save it. And again, let's run our Terraform plan. Right, so in that case, again, right, I don't have permission. Access is denied because this user doesn't have that permission to be able to access that region. Right, so you can see that there's different types of errors that are shown. So let's say that we go back to US West 2, which is the region that I am defaulted in on my profile anyway. And let's use it. But let's make a change to the file. So let's say that we're now going to upload index1.html. All right, so we've changed something. We're going to upload index1.html. And at the moment, that doesn't exist. So if I tried to run that would be unsuccessful. So let's go in here and just copy it here. Let's paste it in. It's going to say copy. So let's call it index 1. By the way, all it says is hello world in the file. So this is what it looks like inside of that index file. But I'm going to rename it. So at some point, we've decided that index.html is no longer valid. We've now done an update, right? So index 1 is now the valid one that we want to deploy. We're going to go back to our object here, and we're going to go and plan to see what's going to change. I think I saved that. So notice it says refreshing state, right? It read that there was an index.html, but it says, wait a minute, I see that you want to do an update. And the update basically is mentioned here. So it's recognized that we've made a change to the file. We no longer want to use index. We want to use index 1. Of course, we can then go and apply that change. And you'll notice if I went up here, the plus, right, the metadata difference, right? There's a new tag for this that's being corresponded to the change that we're making here. And again, we would apply that. And that should go ahead and make that change for us on the application itself. One of the things I also mentioned earlier is that we could do an auto here. So as far as this command goes, we could tell it to auto acknowledge that. So I don't have to say yes every time I want to make a change. That's pretty common to do. But again, from our perspective, I want you to kind of see what's going on here. So here, the update in place, this is what we're making changes to. There's the update of the file. And do I want to do that? Yeah, absolutely. So let's say yes. It's going to go ahead and do that, right? One change, right? 0 to destroy, nothing to add. Remember, we said we can make a change, we can do an update, or we can remove something. So one change has been made. Again, if we do our AWS command, so AWS S3 LS, and in this case, let me just grab that name because I don't remember what I called my bucket. So there it is in my file. So I'll go ahead and paste that there with a slash, and we should see two files, right? So the files are there. So the file got moved and changed in place. So index has now been updated. Again, these are just different, minor little things that we're doing to the files as we're making changes and as we're adjusting the output of the information that we're using. So each time you make a change, the capture of that. So let's go back to our file for a moment. And let's go in here to our workspace. And let's see what the TF state file says now. All right, so here you can see the information in the TF state file. I didn't show you the first time, but I want to show it to you now. And you can see, who the bucket owner is, what region we're launching in, where that bucket's available from, and again, the file and so on would be here, index 1, right? If I look at the backup of that, which is here, right? Again, thinking about this being auditable, if I look at the backup of it and we go through, there's the old file that was being used. So again, that change was made, and then that file was made available to us to work from. So what happens over time, right? What happens over time as we're doing something like this? What kinds of things are we going to want to save, and what kinds of things are we going to want to see in those commands? That's entirely up to us. So we have a bunch of choices here to make as we go through the environment, and we have a bunch of choices to decide upon, what should we be doing in those environments. Does it show who made the changes? Yes, it can. It will actually keep track of that. In my case, I'm not logging in. So just to quickly answer that question, Neil, I'm not logging in, but if I was using the login pieces through Terraform, using the Terraform cloud, I would be able to see that. Otherwise, I've got to look at this information somewhere else, right? I've got to look at it at AWS. So it depends on what I want to do. In a global infrastructure, it'd be more likely that those changes would be made by me, and I would be tracking that through probably one of the cloud tools. There's a bunch of them out there that are used, CloudWatch and so on. But that would be where that would be done normally. The idea is right now there's only me because I'm only running this locally. So it's this user, me, that's looking after that and provisioning it. But if I'm checking this into a larger system, I'm probably using GitHub or GitLab in that case, then yes, I could track those changes because I would be doing commits, right? And when you do a commit to that, obviously that would be the correct way to do this properly. All right, so we saw Terraform apply, perfect. We applied our changes, whatever, and it launched the resource. The other thing that we could do is destroy the resource. So this will move infrastructure and destroy it. Again, that's just a command that we're going to use from the command line. Oops. Somehow I kept the key down. So, sorry, you'll see my key got stuck there. Terraform destroy. Now, again, same kind of thing. It's going to look at what resources are out there and in use. It's going to look at the resources I've already provisioned, and it's going to say, what do you want to do? I've noticed in the file, you're telling me you want to remove this. So again, right, it's telling me what it's going to remove. Notice all of this is around my bucket, who the owner is, and so on. And then what it's going to destroy, will be down here, right? So essentially what I want to destroy is that file, and I want to remove the bucket. So here, notice it says, I will destroy it if I can. But look at this. Bucket is not empty. So one of the things that we had in our file was that we didn't want that bucket to be destroyed if it's not empty. And that's a provision that we can set, whether it's in CDK or here or elsewhere. We can prevent the destruction of our files. And if you think about this, that makes sense, whether it's on Azure in Azure File or somewhere else or here in AWS. It makes sense that we don't do that. And there's a couple of reasons behind it. Big one being regulatory reasons, right? That we're not allowed to basically remove those raw files. Think, Sarbanes-Oxley, SOX, SOX2, things like that. Bill C-198 in Canada. Anything around financial data, we would want to lock that so that original raw resource can't be removed. There may be other reasons as well, right? In larger organizations, through the audit process, we may not want you to be able to remove things that are being stored out there. So that is a change, by the way, that we could have made in the file. We could have said, yes, we want that destroy option to delete that in our bucket. But in our case, we didn't want that to happen. So we didn't add that information in. But if we did want it, yes, absolutely, we could destroy it. However, remember that it is, right? It is auditable. So again, if I'm using some kind of the cloud tool out there to monitor the situation, we could track that somebody did try to destroy it or remove it from the folder, and that might raise an alarm or an alert. There's all kinds of things that you would not want to do here. So these are safety mechanisms, just like anything else, right? We're preventing something from happening because, X, Y, Z, whatever the scenario might be. Same thing for launching in regions, right? We may have restrictions on where we're able to launch. And again, that may be regulatory, right? If I'm in the US, I have to maintain data in the US. I don't want to be like Google or Microsoft and get fined millions of dollars for taking data from the European Union and storing it in the US. All of these things have to be considered. It's beyond Terraform. Those are policies that your organization will set, and then you have to decide how to enforce them. So we've seen a couple of examples. This is an example of an EC2 configuration, just to show you that up front. Here is the configuration. This is all the provider information and the Terraform versions that we're using. These would be specific, right? So depending on what I'm running. And then down here, there's my provision of the region that I'm going to use, US East 2 or US West 2. The AMI would correspond to the AMI from AWS. And again, if you're familiar with Azure, I can show some of that towards the end here, but essentially we are talking about creating an EC2 instance here. So that is essentially the hardware, right, our instance. And when I go into launch an instance in my dashboard, I have to pick an AMI image. So what I've done here is I've picked, an AMI image that exists. They're all listed here. There's lots of them. And I've picked the type of instance that I want to run on. So if I pick, for instance, here in this example, Amazon's Linux version, and then I go here on the second screen, I've got all kinds of provisioning environments, right? The hardware that I want to run on, and you can see that there's lots of them available. I won't again go and do that. That's not the the important part of that. It's just the fact that we can actually put that here in a file. Now, we could also put that in a variable. So if we have different requirements, then we could have a variable list of the different AMIs and a variable list of the different, in this case, instant types that we want to deploy. And that would make this more flexible, right? So again, all kinds of things like that are possible. I'm just showing you an example here of that. And then it's just a matter of, creating an instance. So this one's setting up a, public IP address to be used by this particular EC2 instance when it launches. Again, there's lots of examples of this online that you can look at. I'm here to kind of talk a little bit about how it works and so on. I've been doing a bunch of demos ahead of that, but hopefully it's making sense to you. You're getting a chance to see how some of this might work. Also, some of the pitfalls, right? We've already talked about some of those things that we need to consider, like if I'm working with a bunch of people and we're sharing, right, resources, we need to make sure that our shared resources are also using some kind of shared, probably login for IAM. But again, these are all, kind of things that we have to consider overall. How are we going to do that? There's lots of additional configuration management tools out there. If you're configuring your environment, Terraform is basically for manipulating a set of components. Kind of what somebody asked earlier. What if I need 5 instances, but I only find that there's 4 out there? Well, Terraform will make sure that there is a 5th one added. So from that point of view, some of these other systems are great at automating, but they don't monitor and keep track of what's going on. And as I said, this is something that through Terraform Plan and Terraform Apply, we can ensure happens. And then on top of that, applying things like scalability, those kinds of things, load balancing, all of that can be done as well. There is some drawbacks of all of this kind of stuff, and I think a few of you have already raised some of those concerns, like what happens when it gets destroyed? That could take all my infrastructure down. Well, again, you're going to set policies on that so that can happen, right? You're going to set other things within the environment to trigger on that if something does happen that's not desired. Again, that's the backup of it. It's not Terraform's responsibility to do that. It's your responsibility in your environment. Again, a little bit more about some of this idea, but the main one is down here. Every time you run it, it maintains that information. We saw the backup file that maintains that state information. So what's the current state? What was done before? The plan will tell us what's going to change as we're going through, and it will figure out. What I always say is, what's the current state? Terraform has the new desired state. And as we change from desired state to current state, then Terraform in the next plan will have the next desired state. But it's always maintaining what the current state is and what the previous state was in the state file and in the state backup file, which is a good thing, right? We know exactly what's happened out there. What if I need to know what's out there? Well, remember, Terraform import allows me to import and return that information. So we've got mechanisms available to us. We could also run Terraform show, which is another command that's available for us. which I didn't do earlier. So Terraform show. Let's spell Terraform correctly. There we go. And it will tell me what's out there, what resources are currently in place. So the only thing that we actually have in place, right, is that bucket that we created in US West 2 with the index.html file in it. Right? Nothing else, right, has been updated. Right? So again, all kinds of other backends can be used. If you want to maintain state, you could also export this information to GitHub or to S3 or to DynamoDB or CosmoDB or anywhere else that makes sense for the application of this. All right. So again, we do want to make sure that we understand that this works together with other things that you are probably doing in your own environment. So it's not just a one-off piece. There is some drawbacks, right? So for instance, if you think about declarative infrastructure, if you don't have logic that you can build in, then it doesn't make sense to use something like that. The nice thing about this is that we do have variables, we do have output variables, we do have something called modules, which we'll cover in the next chapter. We've got the ternary syntax that can be used, the if true, then do this, if false, do that. And we do have interpolation, which I've already talked about a little bit here in this session. So there's lots of pieces that can be utilized within Terraform. And this really gives us a lot of power using the Terraform platform to be able to work with this. All right, so Terraform files, again, process-based. You get lots of ways of working with it. And once you've got the provider, then Terraform can do this manual configuration if you need, but we store everything in the .tf files in the folder that you're executing it from. So it's, again, keeping that infrastructure available to you. This is an example. So, again, there's the state file. It is an example. And you can see, of course, the information around it. This one happens to be for AWS, but again, different ones are available for you to work with. We actually have two different courses that we run, one 2-day on Terraform for AWS. We also have one for Azure. There's one in the works for Google as well. So those of you that might be looking for G-Cloud examples, we will have those. But again, there are some things to consider here. I'm just going to skip over these. These are talking about additional pieces. Feel free to read through those slides. You do have them. It's a little bit about agents and why agents need to run. Essentially, Terraform is agentless, and so you don't have to, run some kind of additional agent. This masterless, agentless approach is very good for being able to build out your applications. What I want to do is talk about some of these additional features before we run out of time. So again, we'll take a look at this. As far as Azure goes, if you're setting stuff up in Azure, again, those details are available just like we saw a moment ago for AWS registry. There is the Azure registry. And the Azure environment that you see here, for instance, things like networking and firewalls, other types of applications are available as well. Let's look at maybe, this example with sorry, let me go back to the Azure one. Let's look at this example of creating a network, for instance. These examples, again, are on GitHub. So you can hop out to GitHub under Azure for Terraform, and you're going to find all kinds of examples here, which are a lot more detailed than what I'm showing here in class. So going back to that question, let me put that in the chat as a link. So Microsoft Azure, and then again for Terraform itself, you'll find different files available here in the repository that you can work with. Okay, so that's where I would look specifically. These ones specifically to this example are under the VNet one. I'll put that, sorry, put that example in here too, for those of you that want to see the Azure examples. And again, the courses that we have do detail these in more detail if you want. But here you can see the resource, right? Let me make this a little bit larger. Here's, how you would use it, right? Setting up the VNet. As I said, this is the same as a VPC in AWS. There's my subnets, right? And I'm going to deploy whatever it is I'm going to deploy. This happens to be setting up the subnet with access for the security role. Here's the routing table information. You can see that this can get quite complex to build out, a full configuration for this environment. And again, you've got lots of choices for utilizing the different examples that are here. Do take a look at those in particular. Other than having a couple of examples of AWS, this is a generic slide anyway, so we use the same ones in both courses. Again, you typically would put your command someplace. So in a Linux environment, it might be under OPT Terraform. In my case, I showed you earlier, I just put it in the directory that I'm under here in the workspace as an example. That's not where I would normally run it from, but just to show off here in the course, that Terraform exe file is here in Windows and it's sitting under the directory I'm running from. But I would more likely have it under a path somewhere. And, I would obviously refer to that path in my environment variables or in my system environment variables. Again, there's a couple of the additional ones. Show is here, format is here. We didn't talk about those earlier, but that just shows you some of those commands. First command you always run is initializing the directory. You saw me do that. That created the state file. It created, of course, the resource file that it downloaded. It was appropriate for the version of the registry that I'm using. Remember, that's in the file that I'm working from. So within that file itself, I normally declare the version. We saw that a couple of times here, right at the very top. So this is the version of the HashiCorp AWS that I want to use. These versions change over time. You probably want to use the latest version. So again, when you download the file, it will bring down the appropriate version that you want to work with. But for that particular provider, it will download that version and use it. So in my case, what I did was I left that off when I downloaded it, and you'll see that I have version 3.743 here. So, again, I can modify or update the versions, and then it will download the specific software for me from Terraform for that registry that I'm going to use. Pretty much all of these commands are straightforward. We mentioned about the state. The current state is kept in the Terraform state file. That's the one that I look at. We know about the backups. We already discussed that. We would normally check that into version control to ensure that that information is saved. If you're working with a remote state, there is a remote state capability that can be done. There are also products that do that for you. Most times, my organization, we just use S3. Or you could use something like Dynamo or Cosmo, as I said earlier. It doesn't really matter which data store you're using, but you do have lots of options here to do it. But some kind of shared lockable storage system whereby it requires credentials to get into would make sense in this environment. This is the directory structure that I was talking about earlier, and I've shown you some of it already. So the idea in my workspace, I've got my file here and I'm working with it. More likely, I would probably make some kind of directory here. And within that directory, my folder essentially, I would probably, call this something like Terraform S3, right? Whatever I'm going to call it, it's going to make sense because that's where I want to bring in, my S3 piece. I'd move that there. My data piece would probably go in there. The TF state stuff would stay here on the outside, but that's where that information would get stored. I would create a bucket, essentially, or in our case, a folder, and I would store it into that area. It just makes more sense logically to do that, especially in a larger environment, than just having them all in a single file. However, I have seen some very large single files called main TF that is the complete provisioning of the application and all of the resources for an organization. Perfectly legitimate to do that, as I said earlier, but logically, does it make sense? Right? So that's something that your organization needs to decide as far as policies go. The infrastructure itself, right? The configuration files are the .tf files. By the way, you can also create these in JSON if that's easier for your organization. You just call it .tf.json, and you can use the JSON file. It's acceptable to do that. Again, the validator doesn't work with that, but again, you saw that the validator is not fully capable of reading everything in the file. And then, all of the files are basically the desired state, as I said to you earlier. There are some other ways of working with this where you can override your files if you want. Again, generally don't recommend that. You've got the backup anyway, so if you're making a change, make it to the file, check it in kind of, as we're doing by doing the plan, and then when you apply it, the state will be saved. So remember that TF state has the current, is what's current, and TF state backup is the previous. So again, these are the things that are important to remember. As far as the load order of the system goes, if you're using a directory structure, as I mentioned earlier, and we do these in the courses in particular, then what you're probably looking at is some kind of hierarchy for your solutions. And this is kind of an example of that. I know it's hard to see, but so I might have my AWS instances. Those would be my EC2 instances. I might have my data. This is a DynamoDB example. I might have a Lambda function running, right? AWS Lambda function. Might have a load balancer. There's my S3. There's my VPC. And you can see that I've kind of created them in those different folders. I do the same thing in the Azure environment when I'm working on it as well. I generally try to have some kind of uniform way of doing it. So for instance, this is just a quick example of, I could have CosmoDB here, but I'm going to have a folder for CosmoDB, and then I'm going to have a folder probably for AKS, and I'm going to have a folder for, different other pieces like the VNet that I might create in Azure. It just makes more sense to do that. Now, when the files are actually used, Terraform looks after the file itself by loading them in alphabetical order. Now, wait a minute. What's the importance of that? There is no importance. It's just telling you that that's the way that it's done. They actually configure all of that together or append all of them together in a single TF state file that gets run. And they look after the execution order. Okay, so they know what the execution order is. In other words, they're not going to execute an EC2 instance if there's no VNet, VPC. They're not going to execute, in Azure, the actual VM if there's no resource grouping and no VNet for that resource group to be put into, right? The subnets need to be there, other things. So that's the important thing. It really recognizes correctly the environment that you're dealing with and uses it effectively. So the format, HTML, as we said, is a little bit more readable, but you can also do JSON This is the HCL example. We've seen a few of those, so I won't really stay on it, but here's kind of the idea. And you can run multiple instances. So here, somebody asked earlier about how do I set up and run multiple EC2s. This would be the way I would do it. I would set a count value, and that way I can run 2 of these at a time. There's other things that we can do through looping, I think I mentioned earlier as well, that make this a viable way of working with the application. So you've got lots of capabilities here as you're working through it. Okay. I mentioned about string interpolation. This is a good thing if you're working with variables and you want to do something. So here maybe I want to have outside a reference to the AMI version. So you can see here that we can have value expressions that are started with the $sign. It basically uses a very Linux-like style for the way that things are done. So you could also see another example here where you might have a specific resource that you want to use and you want to call it something else. So again, possibility to do that. For example, there's a lot of built-in functions in Terraform that you can work with. So you can see more about that if you want here in the documentation about interpolation as well as the built-in functions. We're not really going to go through them. We just don't have time here in this particular session, but in our larger class, we spend a lot of time talking about some of the built-in functions that you can take advantage of. There's things like mins and maxes and all kinds of things like that that are available for the variables as well. Typically, when you're working with it, you're building it up in 2 parts. One is the data source, and the other are the resources. Data sources are kind of read-only views of your environment, so the current state, essentially, of your infrastructure. Things like, give me a list of all of the AMI images currently being used. Find a particular VPC for my deployment. So this is a way in which it's organized. And then the second part of that would be the resources that you want to define. They're defined basically as components. So you would create an instance, you would create the subnet, you would create a router, and so on and so forth, or an S3 bucket or a Lambda, whatever the case may be. It will be specific to your environment and what you need to do in that environment itself. Lambda functions, any kind of thing like that that are kind of higher level, you do have the capability of working with. Remember that Lambda functions are serverless, so you do not have to provision EC2 instances, or in the case of Azure, the VM, that's not required. So here's kind of a quick example of what a serverless application like a Lambda function might look like. We tell it the type of runtime that we want to work with. We tell it where our functionality is within our application. And then what it will do is, of course, build up our application by whatever it's called and whatever description we give to it. At that point, right, we can fire events against it. We can work with jobs against it. There's all kinds of other things that can be done with Lambda events. But again, that's outside of the course here. That's more EC2 or AWS or S3 or Lambda specific. That's why I said at the top, it's important to understand that. In our introductory classes, we actually do take the time to go through and learn about AWS as well as Terraform at the same time over the 2 days. We have more advanced classes if you already know about AWS and you don't want to specifically focus on that. You only want to focus on sort of the Terraform code. We can do that too. But I often find it's good to have both, especially if you're new to some of that and maybe you don't know about specific things like a Lambda functions or some of the RDS stuff in particular, or some of the NoSQL components. Again, focusing where we need to make sure that everybody's successful. Here's an example of using a variable. So you can see on the outside, this is essentially what we would create. We could also pass that in directly when we apply our functionality. I think I mentioned about that earlier. So there's a couple of different ways of working with variables in Terraform. So if you want, you could create a file and put it in the directory and then use it. I showed you the Terraform TFVAR file earlier, in which I had the credentials like username and password and so on. Again, another example here of setting up the base URL for something like a host file, and then of course calling it later on by using interpolation. So here, the interpolation being var base URL, because, again, that's the variable and the name of the variable that we created. And that would simply use it in this case. We can override them in other ways as well. So if you needed to override some kind of environment variable, you could use the tfvar file for that. So tfvar, base URL. Notice that we're exporting that, and now it could be some additional URL instead of localhost. Maybe we've got finally our domain has been approved and we've got our domain name that we want to use. Now we could override that. And then, as I said down here at the bottom, applying it as required when we run it. This, of course, is the Terraform TFVAR file that I mentioned, or using -var file name on the command line as we see here. So again, all kinds of ways of working with variables, and that makes it flexible for the environment that you want to use. That also gives us that reusability that we talked about earlier with Terraform specifically. That reusability is something that we want to take advantage of. And again, this gives you that flexibility as you require. In addition to variables, we have outputs. Again, you can use a configuration defined output, so output address, and apply the value, and that will return the value to you. Again, you access that using the Terraform output command. Remember, I showed you earlier, there's a bunch of commands in Terraform that are available for you to work with. So this is the output one that we're talking about. And again, shows the output values from the module, and then you could, understand what's there. You could even collect them together. Tell you how I use it. I use it with a pipe command, right? So if you think about doing this in Linux, when I run something from the command line, I can have it output into a new file, right? Just use the append or greater than symbol to do that, and makes it easy to get those variables and have them stored and available in my then TF var file if I want. So again, lots of things like this are possible, but this will give you the output. Data sources, all kinds of data sources in use, as you probably know. We can get that value from outside the configuration. I mentioned Terraform show. So we saw that earlier. So here, Terraform show shows me what's currently set up. I can take that value again and save it out if I want. This is pretty much the same command that I use to basically create the environment. So why not? Notice this one. This is the one I was mentioning earlier. So force destroy false. What does that mean? It means that I'm protecting that file so it can't be deleted. If I change that to be true, you can imagine what it means, right? It means that I'm able to clean that resource up and remove it. So things like this, you may want to do, setting different values and so on, and then use those within your application. You can see a couple of ways in which that might be possible. So this one's using data AWS VPC, and then when I want to use it, AWS VPC, and I can get the ID of that by affixing it as required for my application. Again, Terraform has a lot of these. These are just minimal examples because we don't have a lot of time to go through them in the 2-day course. We spend a lot more time doing so. Providers, again, we mentioned about that earlier, whether it's AWS or GCP or whatever, these are plugins. You get them from the registry. Again, work with the particular version that you want. providers are downloaded when you do init. And you remember mine was 3.7.3 is the latest version, but I was overriding it in the file to 3.23. It's perfectly, legitimate to do that if there's some particular resource that you want or some particular piece that you need. Again, this provider allows you to work with the AWS or Azure API. It doesn't really matter. Both are the same thing, same commands pretty much. The only difference is when you call the resource, right? So when you call the resource, you make sure that you're using the proper definition for that resource, as you can see here. So in this example, right, we're creating a T2 micro instance based on some AMI, which is outside of our application, right? It's Ubuntu ID that's being used here for the Ubuntu API, for the, AMI. We're providing a tag called Hello World, and we are calling this thing web. So later on, right, this will be web. Now, somebody asked me earlier about changing up tags. Well, it's just a variable. And if you use a count, then you can essentially go through and increment the count, and you could apply a different name here to each instance of that EC2 that you want to launch. Let's say you want to have 10 and you want to number them from 1 up. Well, okay, do that. Right? 1 to 11 would be available to you. So again, different resources that are available for you to work with. Resource defines the output in our configuration, and the actual ID of that created resource is then available. We saw this a couple of times, and I kind of didn't point it out, but you can see that in this case, my bucket actually has an ARN name, which is an AWS feature. If I was doing this in, let's say, Azure, then again, I'm going to get similar information for the output of that. And the TF state file will be similar. So just to show you that, I want to make sure that, I fairly show you kind of both sides. So here is lineage again, right? This is the Terraform state file. And then here in my backup file, right, you can see this is stuff that I have provisioned on Azure. This one was creating a Linux environment for me to run. There's an ingress to allow access to my Linux environment from the outside. A bunch of other things will be in here in the file. Right? Virtual machine, right? Information, as I said, the type of virtual machine, where it's running, and so on. Disk encryption that was set up on the environment. Right? This is the backup file, so you can see that this one was an example AKS in West US 2, and there's the outbound addresses and inbound addresses. Kubernetes was being used, and load balancer was created. And so all kinds of things here that we can do, including, of course, looking after that under our group in this case. And there's the ID that it uniquely identifies, right? That asset that I have in the cloud, right? So that information is available for us to review. It gets generated for us. It's not done automatically, right? When I create this, it's going to generate the ID in that remote resource, whatever that might be, right? In that case, Azure was that example. Just to be fair, to show both sides. Providers, again, are extended. So again, over time, you may want to update them. So you may require additional things in the variables to be able to make those resources work properly. And you can add the resource type, which is the normal thing that you do. Without the provider, there's no resource, meaning no capability of deploying whatever that is, right? So here, I got to say the resource. Then I can get at the properties that I want to work with in the resource. And without that provider, I'm going to be in trouble. So I need to make sure that the provider information is there. Okay? This is generally a must. So a couple of examples there just to show you where that goes in. Lots of providers, as we said earlier, not really going to go back through that. We do a deeper dive in the main course on that. Here's configuring, right? Whatever we want. So one of the things that I mentioned to you is that you can provide definition about that. You can provide additional information like, your secret keys and so on, and those can be in a separate variable. So this is a good example of that. Providers have different requirements as well as different configurations. So you need to look specifically for the provider itself. That is an important piece. And by the way, this creates what's called a lock file in your folder that will then only reference that provider. So going forward, this information in the lock file is maintained by Terraform. And all of this is referencing the versions and so on. Anytime it talks to the provider, it passes this information back and forth, and it maintains that connection. So you'll see that that goes under here. When you run Terraform init in the folder, it basically creates that log file the first time. And you'll notice it says HCL on the end. It's just HashiCorp notation for it. But that now locks that folder and all of the files in there to that particular type of Terraform deployment. Okay? It's an additional file that's there with, again, specific provider versions registered to it. So it reads that each time. Now it can use that and provision whatever you require. More information again in the file there that I shared with you earlier in the class. Modules are very, very useful here for reusability, shareability, testability, and so on. We see a lot of organizations using modules as an effective way to share the resources among the data engineers and data scientists that may be using them. So this is something that is typical out there, and you'll see it's pretty easy to work with it. In this case, we've got web servers as a module, and we've got a count of 4 of them. So this configuration would allow us to have, by calling this module, 4 web servers launched each time that we need it. It would be, of course, good idea to store that information someplace, your modules as external libraries, and then it's just a matter of calling the module when you need to use it in your Terraform script. Again, modules are kind of an advanced feature, but it is something that you need to be aware of with Terraform and how it works. So to define the module and use it, you might do something like this: module.webservers.subnet-id. So again, using some kind of interpolation. The location of that should be set somewhere, right, or in the repository. Now, up until now, everything I've mentioned, when I said main, there is a main module that's typically used to reference all of the sub-modules. So in this case, here, this would be where I would start to reference this module information. And I would start to put that in here and say, these are the modules that I also want to use with this main module. And if this is set up properly, then that information is going to allow me to access possibly subfolders, like you see here with CosmoDB, or in the larger example that I showed you earlier inside of Terraform, right? I have a whole bunch of modules here in AWS that I might access from a main module on the outside. So that would allow me to provision a bunch of pieces at once if I require them to be used in the application of my Terraform. So again, whatever is I'm deploying, right? This is really hard to see, and I do apologize. Let me just try to blow it up. But this is kind of the idea of there's my modules, and then here's my different folders that I'm using. But globally, I have my main, TF that's going to be used to deploy those additional modules. The thing I don't like about this one is they show main TF, main TF, main TF. This is what I said earlier. I would rename that. So if this is my data store, it's a MySQL data store, why not call this MySQL.tf, right? Just makes sense. Again, that's typical of what I would see in real world usage. And again, it will find all of those submodules as required because it looks for the .tf file. Configuring up the provider, very, very important. We talked about this earlier. Again, typically two things are required minimum. So these are the minimum requirements. You may have additional pieces that you want to use, like your access keys. As I said, in my case, I don't need to do that because of the fact that I'm running on my local machine and I've already done, my AWS configure. So some of you may know about this, right? I've already done this. I've gone AWS configure, and that allows me to put in my IDs and my codes and what region I want to default to. If I'm doing that in Azure, I would do something called Azure Login. And Azure Login provides that same kind of information. It downloads it. Typically, I would do that not here in the command line, but I'd probably do it through PowerShell. Again, just different mechanisms that are used to set up the initial configuration. And then this example, as it says, you probably want to create those keys in some different ways because these need to be protected. You don't want those to be checked in. I've seen this happen, by the way. I've taught many, many courses over the years, and one of the things I often see is folks leave that file and then it gets checked into Git, and in about 10 minutes, the AIs in AWS or Azure or Google shut down your account. So you need to be very, very cautious, pardon me, around how those credentials are saved. Don't put them in your version control system. Again, this is probably the better way to do it. There's other ways as well. Right? Pardon me. All right, so just some examples there. Again, same thing for Azure. It's actually better in Azure, but configuration. So again, Terraform EC2 instance with your IAM credentials. So you can see the idea here is we get the IAM credentials, and then we use our AMI to basically run this application. Right? So the combination of these two components provide the provider along with our environment variables for our credentials, and then we can start to run our resource, whatever that resource might be. Right? Makes more sense to do that. DNS entries can be done as well. So if you run your own DNS, Active Directory can be used, right? Here's an example of working with that, setting it up. So again, go ahead and do whatever you need to do. I would suggest that you're probably going to use resource groups and so on, which is generally a better way to approach this anyway. Generally works better for everybody involved to be able to do that provisioning in this manner, as opposed to doing it by hand. Okay, so let me stop for a moment and let's take some questions because I know there's quite a few there that I've been going through as we've been going, but I want to make sure that we cover off everybody's questions. What have we not done? Oh, looping, yeah. No, I covered that off earlier. Just making sure I've covered all the questions here. Yeah, those look okay. So let me cover a couple of things that are a little bit higher up the framework here, just to maybe touch on them for you. Let's go look at Terraform itself, not the registry, but Terraform. For those that were asking about examples for the different types, what I would suggest first off is come and take a look at the overview of how this works. And then for the CLI, which is what we're looking at in our example, we would probably want to delve into that. There's some great tutorials here for you to work from. So again, if you want to know how to, start with, Azure, for instance, these tutorials that are available are excellent. So remember I said to you, you have to install Terraform, then you're going to build your infrastructure. There's some examples here of defining variables. You'll notice that it's very similar. The only difference is the resource group that's used in Azure is slightly different than what we've been seeing in AWS examples. And then it's just a matter of applying, the application, as I said, that could be applied by passing in the variable as well. So again, good examples here to work from. This is using Azure variables. Let me put that in the chat as a link. Because we did say a little bit about that earlier. But lots of good examples here. As far as the documentation goes as well, there's lots of examples in the documentation to work from. So, kind of about the CLI and so on. Somebody asked about, pardon me, sorry. Somebody asked about specific state. So I just wanted to show you that if you want to know more about state, that is here, and how state is maintained. I kind of covered it off, but just in case, again, they talk about disaster recovery too here. This is the idea of checking it into some kind of repository. Writing your code, so validating here and so on. Looking at the infrastructure is here, so you can actually get a graph. Now, I just caution you, if you use that, you want to be a little bit cautious because it can get quite large in a large environment. But you can provide a graph out there by doing Terraform graph. It'll show you something like this. So sometimes that's helpful to understand what's been deployed. Again, do take a look at that information. As far as working with the language itself, there is a lot of things that you can do. One of the things that a lot of organizations get into is this idea of a workspace, and a workspace essentially provisions out the environment for you so that state data can be held separately. If you recall that image that I showed you of the different pieces, that was very hard to see. That's essentially what the workspace does. And so you can initialize a workspace directory, kind of like I did here in my environment. And then with that workspace, I can, keep everything managed in one area, which if I'm checking something in and out of a repository, kind of makes sense. That way, different things can be provisioned for me directly in that workspace. Pardon me, my allergies are acting up today. do apologize. But these are kinds of the things that we would look at. What happens if we have many, many deployments was a question, and how do I keep track of that? So let's say we have dozens of resources that are out there. There's two different ways of doing it. One would be in the CLI and using environment variables and variables. I would use that. The other option to that would be Terraform Cloud. And so again, Terraform Cloud does have some kind of provisioning for you. That's a paid service though. So some organizations do decide to use it, others don't. So just be aware that that is a paid environment that does cost additional money. One of the other things that I mentioned earlier to you was with the CLI itself, there are lots of commands that you can use in here. So just to show you where that is, here's a link to that as well in the chat. So terraform.io/CLI. This gives you the language documentation if you want to know more about kind of how Terraform works and how the language works. These are all great examples of that. But as far as the additional commands that we were talking about, there's a lot of information here on provisioning the infrastructure, setting up your plugins for your environments, of course, working with some of those additional commands that we mentioned, modules in particular. So Terraform modules, I would say by far are the most sought after piece that people want to know about because the organization of things are often done in that way within larger organizations where states need to be maintained between systems. So do take a look at this if you're looking for more information. But take a look at some of those examples that we showed as well through GitHub. By far, there are hundreds of examples from the registry for the different providers. Just make sure when you're doing this that you use the right ones, the official or verified ones. And then you'll see down here on the left-hand side, there's different categories. For instance, if you're working with databases or something like that, right? There's Elastic Stack, there's Mongo, Atlas. Here's Redis. My environment, we use a lot of Redis stuff. As far as other things, web services, if you were setting up something for web services, these are the different ones that are out there. There's a lot more in the community as well that you can look at, but some of that are verified for the specific environments that you might be looking at. Again, do pick the specific provider. So if it happens to be AWS or Azure, again, use the specific one that's appropriate for the environment that you're working in. I think by far that would be the most important kind of takeaway. All right, so I was going to use the last kind of half hour to open the floor for questions, see if there's anything that we haven't touched on yet, something that you might be interested in or still curious about. And by the way, thank you for all of the questions. I've been trying to do my best as you've been posting them there to answer them as they've been coming up. But if I happen to miss something, please let me know. I'd be more than happy to go back and talk about that as well. So opening up questions there. If there's something I missed, let me know, please. I've done such a good job. There's no questions. Oh, well, thank you. Appreciate that. Don't forget, there is a lot of information out there already. GitHub is an excellent location to go to from Terraform and look at that information. If there's something in one of the commands that you need to know more about, it's generally pretty easy to Google it. right? If we need to know more about modules or things like that, there's lots of information out here. This is kind of the section where you would go through. You'll see that there are functions here. I kind of mentioned about the numeric ones, mins and max, but there's other ones as well. You can see absolute, ceiling, floor, max and min. There's examples of using those functions. Mentioned about state earlier. Again, remote state is something that often comes up. People want to know more about. How do we do that? Again, work through that, take a look at it. But if there is, something in particular that you want to know about, I'm more than happy to discuss that. Somebody asked about dot out. I think that was Sarosh. Yeah. So let me put that in here. This is the actual output file. I did touch on it, but this will give you the kind of the description of the information that's returned. Right, there's our main TF file with the values. Somebody asked, are we giving out the files? No. No, the notes are there, the files are not. The files are part of our course here at WebAge around Terraform. So all of these files. But the examples, as I said, I gave you lots of locations to look at for those examples. So please, feel free to go there and take a look. If you do have additional questions, you're more than welcome to send me a question. I have no problem in doing that. And I can direct you as well if there's some training that you think, might be required or you would like to know more about, then, feel free to reach out. I'd be more than happy to pass you along to one of the sales folks here as well. It's not the intention of the course, but it is there. So, does anybody want my notes? I can save these and hand them out too. Why don't I do that? I think I can. Yes, I can. Handouts. Perfect. Yeah, let's do that. There we go. You'll find that in the handout section. All right, well, that's all I have, folks. If there's, any additional questions, I'd be more than happy to answer those. I want to thank you for attending today and being with us. I hope you found it useful and interesting around the different techniques that are out there. Remember, we kind of only talked about two areas, Azure and AWS, but there's certainly lots more areas in which Terraform makes sense today for organizations to use it, including on-prem systems. I mentioned about that. Whether it's something like a VMware or even if you were doing Kubernetes on-prem and you wanted to have it configured by Terraform, certainly is possible to do that. And again, we see a lot of usage of this out there in the community, not just in US and Canada, but Europe and Asia Pacific. There's lots of applications. So again, I guess we'll wrap up then if there's no other additional questions, and say thank you very much for joining the session today. This is recorded, so I believe they're making it available. So if there's somebody that wants to be able to learn about this and learn about it in a quick way, hopefully you'll be able to direct them to that video. I believe that'll get shared with you after the class and be made available on YouTube. So again, thanks everybody. Nice to meet you all. Wish you the best of luck in using Terraform.